Hello, geometry folks. Welcome to day 5. We're still talking about angles and arcs and figuring out various angle or arc measures. And today we're going to look at a case that is different from what we've been talking about. Before I move into the notes, I want to remind you so far what we've covered. So far we've covered central angles like that, where the angle has a vertex on the center and the angle is equal to the arc. So if this is 50, this is 50. And we've talked about inscribed angles, where the vertex is on the edge of the circle and the angle is equal to half of the arc. So if the arc is 50, then the angle is half of that, or 25. But today what we're going to be talking about is a whole nother situation where our vertex is somewhere inside the circle. And I'm going to highlight this for you. I want you to take a quick look at this angle. That vertex, the green point for our angle, is definitely inside the circle. However, it is not, we put here vertex, is not on the center, and it's not on the edge. It's just somewhere inside. And this is a whole nother case. This doesn't fit in to any of the situations that we've learned about so far. So what's important for us to understand is that this angle touches here and it has an arc. But then remember, this angle has a vertical pair. Remember how it has a vertical angle partner where they're equal. So it also has this red arc. So instead of having one arc with our central angle or one arc with our inscribed angle, in this particular case, we have two arcs that are related to that angle. And we're going to learn about that today. So just kind of wanted to set that up for you. So this is the case where the vertex is inside the circle. It is not on the center. So these are two secant lines. And we're going to take these two arcs. I'm going to highlight them. They're bold in the notes, but I'm going to highlight them in purple. And I'm going to highlight the angle in yellow. So there's the angle, or there's the angle. And no matter what angle we're talking about, whether we're talking about angle ABC or we're talking about angle EBD, they're both the same size. They're both vertical angles. So they both will have the same arc intersection on the edge of the circle. So what we do is we take the first arc and we take the second arc and we add them up and we divide it by 2. So when the vertex of an angle is located in the circle, but not on the center, the angle measure is half of the sum. Remember, sum is adding of the intercepted arcs. And when they say intercepted, that's just where the angles touch the circle. Okay, so let's take a look, a couple of examples before we come back together. So here it says find x. And I can tell that x is an angle and its vertex is kind of shifted off to the left. So it's not on the center of the circle. So this is not a central angle. X is not 130 degrees. So we have to look at this particular case and figure out, okay, well, it touches T to U. That's one of our arcs. And then if we consider the vertical angle buddy, there's its vertical angle buddy. And then that arc touches from R to S. So those are our two arcs that we care about. And we're going to use the formula that we stated up above. The angle equals arc plus arc divided by 2. So it doesn't matter what order I add the arcs in. We're still going to come up with the same amount. And if I do that in my Desmos calculator, which is totally cool to do, what I'm going to do is get a fraction bar. I'm going to click on the division symbol. And then I'm going to type in those numbers. Then I'll use my arrow button to divide by 2. And that's where I'm going to get 107 for X, for my angle. Oops, wrong class. So sorry. So the biggest thing is identifying those two arcs. I think that's probably one of the most challenging things for students. So here's a more challenging problem. If you look at X, X is here. So here's my angle. Here's my vertical partner. And here's their two arcs. But I have a problem here. And my problem is that I don't have any arc measures. I mean, I do. I have the 62 and the 136, but those don't go with my angles in my arcs. So I have a little bit of a problem here. But what the 136 and the 62 do, let me show you what they're helpful with. I can find this angle or that angle. Those are vertical pair buddies. And now that helps us use this and this. And some of you may be wondering, yeah, but Miss Lucas, that's not going to give you X. That's going to give you this angle or this angle. And I promise you, I will find the correct angle. But this is kind of like a two-step question. So I have to find EAF or HAC. And what the problem is saying here is that step 1 is to determine the measure of EAF, which we can do. We can say 1/2 136 plus 62. I'm going to go over to my Desmos calculator. I'm just being lazy here and not retyping it. So I get 99. But of course, that's not what I want. This is 99. I want the one that's right next to it. I want the next door neighbor. So I'm going to just scroll down a little bit and I'm going to draw that line. Okay. And I'm going to show you, here's my 99. And here's my X. And I didn't draw the rest of the circle and I didn't draw all the arcs. I just drew that straight line. And hopefully by doing that, you can recognize our old friend from way back at the beginning of the year, the linear pair. And remember that the linear pair adds up to 180. So if I know this piece is 99, this is like the old, I have $180 to spend and I've spent 99 of it. How much is left over? And that's going to be 71. And I'm going to double check that calculation because I really don't trust my mental math. 81, see? 81. There we go. So this X value is 81. So it's really important that we take the time, use the packet, use a pencil, use a highlighter, whatever you've got, and highlight those angles and highlight those arcs, because that way you won't run into the problem of not finding the linear pair. Okay, so when we come back to class here in just a moment, we're going to be on page 20. We're going to turn the page and we're going to have a mixture. We're going to have some where, look, the X is in the wrong place and we'll have to do the linear pair. We're going to have some like this where we know the angle, but we need to find an arc. And we're definitely going to need Desmos for that. So I will see you back in just a couple of minutes. Thank you for your attention. Appreciate it.